Welcome back, everyone. I'm Travis with Linux Academy. In this lesson, we're going to talk about services. An application that is deployed out to a Docker host running in swarm mode is deployed out as a service. When a service is created, it is accepted by the swarm manager, and the service definition represents the desired state. Based on the number of replicas, the swarm will go and schedule replica tasks. And each task invokes a single container, and these containers run in isolation. When looking at the diagram, we have a single service. It's an Nginx service with 3 replicas. The swarm manager is going to go and schedule out the 3 replica tasks, and those tasks will be scheduled onto an available node within the swarm. When the container is live, the scheduler then recognizes the task is in a running state. If for whatever reason the container fails a health check or is terminated, the task is also terminated. If the minimum number of replicas is not met, then a new task will be scheduled and created. Now let's go and jump on our swarm manager and create our first service. In a lot of ways, creating a service is very similar to going and creating a container. But rather than executing docker container run, you'll be using docker service create. So we're going to be creating an Nginx service. Go and execute docker service create. Again, we use the D flag to make sure our service runs in the background. And we also have the name flag. I'm going to name the service Nginx_service. Just like with docker container run, we have the P flag to go and publish ports. We'll be publishing port 8080 over to 80 on the container. We are being introduced to a new flag called replicas. This sets the desired number of replica tasks. Now we supply the image that the service will be using, which is Nginx, using the latest tag. Optionally, I can supply a command. To go and list services, we'll be executing a docker service ls, which returns the single service we created, Nginx_service. We can see that the mode is replicated and that we have 2 replicas. The image is Nginx latest. We have our published port of 8080 mapping over to 80 on the containers. Just like with regular containers, we can go and inspect our service, execute docker service inspect, and then the name of the service, which is Nginx_service. Jumping to the top, we can find the spec for our service, the name, which is Nginx service, any labels, which we don't have any, and then we have our container spec. We have the image, which is Nginx latest, and then the ID. Our init is false, we have no DNS configurations, and isolation is default. Under mode, we can find replicated, and that we have 2 replicas. Down at the bottom, we have endpoint, which goes and defines the spec. The mode for the endpoint is VIP, and we also have the port definitions. The protocol is set to TCP, the target port is set to 80, and the publish port is 8080. Then we have the publish mode, which is set to ingress. And this information here is being replicated down under ports. Finally, we have virtual IPs, which goes and defines the network ID. This is the network that our containers will be attached to. And then we have the address. Now, using this ID here, I can search for the network that the containers will be attached to. By executing a docker network ls, make sure you specify the node trunk flag, and then I can go and grep for this ID. I'm going to clear my screen so I can have more real estate. And now we're going to go and run the command. I know this is kind of out of context without the headers, but I can run it again without the grep. Here's the network. Its name is ingress. It's an overlay network, so this is the driver. And the scope is swarm. We'll be talking about the overlay network in more detail in a future lesson. I can also go and check out the logs for my service by executing docker service logs and then the name of the service. And we are presented with logs from Nginx. And this is because the access logs are being sent to standard out and the error logs are being sent to standard error. I can go and list all the tasks for my service by executing docker service ps and then the name of the service. And you can see that we have 2 tasks. We have the desired state, which is running. We have the IDs for each service. We have the name of each individual task. This one is Nginx_service.1, the image that the task is using, and then the node that the task is running on. Also, we have the desired state, which is running, and then how long our services have been up for. At any point in time, we can go up and scale the number of tasks within our service. Execute docker service scale, provide the name of the service, Nginx_service, and then set it equal to the number of replicas that you want. You'll be presented with the overall progress. Right now we have 2 out of 3, and finally it will update to 3 once those tasks are online. Now when I rerun docker service ps, you'll see that we now have 3 running tasks. We can go and scale the service down by re-executing docker service scale and setting the name of our service to equal 2. And when I go and relist my tasks, you can see that we only have 2 now. The last command we're going to talk about is Docker Service Update. This allows you to go and update in certain aspects of your service. If you go and execute Docker Service Update -H, you're going to be provided with a list of flags of things that you can go and update. I'm not going to cover all these flags, but I'm going to hit some of the highlights. The first one is if you have a service and you didn't run it as detached, you can go and update it by using the D flag. You can also go and update the DNS server, as well as override the entry point. Additionally, if you need to go and update your environment variables, you can add new ones and remove existing ones. You can also go and update the labels for your services, update your CPU and memory limits, as well as adding or removing a mount, and the same thing also applies for networks. I do highly recommend that you go through and take a look and see what options you have available to you when it comes to making updates to your service. When it comes to accessing our service, it works a little bit differently than how we go and access a container running on a Docker host. If I try and execute curl localhost 8080, I'm not going to get anything back. Because the containers are running on different nodes, the service is being load balanced, so I'm not able to access it using localhost. However, I can curl it using either the public or private IP. To quickly recap, we learned how to go and create a service. We also learned how to go and list and inspect our services, how to get information on our task replicas, as well as how to go and scale our services up and down and update them. That's all I have for this lesson. Go ahead and mark it complete.